Black Canyon of the Colorado River. From the cliff edges, the river below looked like molten steel, surging with a power that seemed almost alive, roaring and foaming as it twisted through the narrow canyon walls. It was a river that refused to be tamed, a force of nature that had shaped the landscape for millennia. Engineers sent to survey the site immediately sensed the magnitude of the challenge. They had worked on rivers before, on smaller dams and calmer waters, but nothing had prepared them for the Colorado. Seasonal floods had been measured at volumes far beyond anything previously recorded in the American West, with currents capable of uprooting centuries-old cottonwoods, sweeping away massive boulders, and eroding the canyon floor at alarming rates. Every observation sent shivers down the spines of even the most experienced hydrologists. During their surveys, engineers watched the river break its banks in violent surges, carving new channels overnight, shifting sediment, and leaving debris that testified to its raw, unpredictable energy. One misjudgment, one underestimation of the river's power, could wipe out months of planning or claim lives. These men were not just measuring water levels, they were studying chaos itself, attempting to predict the behavior of a river that had never submitted to human will. Adding to the peril, geologists warned that the canyon walls themselves were far from stable. Layers of sedimentary rock formed over millions of years had been fractured by tectonic activity and weathered by centuries of wind and water. Fissures and hidden fault lines ran unpredictably through the cliffs, threatening to shift under the tremendous weight of a dam. The riverbed was no better. Deep pockets of gravel and sand lurked beneath the turbulent surface, capable of settling unevenly and creating weaknesses that engineers could not afford. Hydraulic calculations indicated that during peak floods, the force of the river could exceed the combined stress limits of every dam built in the United States at that time. To the public, building a dam here seemed sheer madness. Newspapers ran headlines warning of impending disaster, calling the project foolhardy and doomed from the start. Letters poured in from European engineers, seasoned veterans of the Alps, and the great rivers of the continent, all cautioning against such a reckless undertaking. They doubted that concrete could withstand the pressure, that the rock could hold the structure, and that humans could ever control a river this wild. The world watched skeptically, waiting for what many predicted would be a spectacular failure. Yet amid the doubt, a vision began to take shape. The U.S. Bureau of Reclamation saw the potential for transformation, not just of a canyon, but of an entire region. If the river could be harnessed, it would provide hydroelectric power to remote communities, create reservoirs to irrigate parched desert lands, and fuel economic success. Growth in a region that had long been considered inhospitable. Every foot of the canyon was studied, every flow measured, every rock examined. The plan that emerged was rooted in mathematics, material science, and an almost obsessive attention to detail. Engineers calculated, recalculated, and cross-checked every prediction, understanding that even the smallest error could have catastrophic consequences. Amid the chaos of the river and the skepticism of the world, the engineers held a quiet confidence. They believed that human knowledge, foresight, and discipline could triumph over raw nature. They were not merely building a structure. They were attempting to tame one of the most violent rivers in North America, to bend it to human purpose without breaking it. Each survey, each measurement, each sleepless night in the canyon reinforced the audacity of the endeavor. This was more than engineering. It was a test of ambition, courage, and the very limits of what humanity could achieve against the unstoppable force of nature. Concrete, in the 1930s, was still a material of both promise and uncertainty. Engineers were familiar with gravity dams, massive structures that relied purely on weight to hold back water. But Black Canyon presented a problem gravity alone could not solve. The gorge was narrow, the rock walls steep and unyielding in unpredictable ways, and the river beneath moved with a force that could test any foundation. The solution came in the form of an arch dam, a structure designed to curve elegantly against the canyon walls, transferring the enormous pressure of the water laterally into solid rock. The theory was sound on paper, but at this scale, in this location, it had never been attempted before. Every detail of the concrete became a matter of life and death for the project. The mixture, cement, sand, gravel, and water, had to be perfect. A slight excess of water would weaken the structure, making it prone to cracking under the immense pressure of the reservoir. Too little water, and the concrete would cure incompletely, leaving hidden weaknesses that could propagate under stress. Engineers developed meticulous testing procedures, pouring sample batches, measuring temperatures, checking for consistency in color, density, and hydration. Even minor deviations could be catastrophic. Then there was the heat. The chemical reaction that caused concrete to cure generated massive amounts of thermal energy. In a structure this size, uneven distribution of heat could lead to cracking, weakening the dam before it even held water. To control this, engineers devised an intricate system of cooling pipes and water sprays, carefully monitoring temperatures around the clock. Thermometers, gauges, and constant human observation ensured that every section of the dam cured correctly and that each layer bonded seamlessly with the one below. It was science, yes, but also art, a delicate balance between chemistry, physics, and patience. Workers were not just laborers. They were part of an experiment that could decide the fate of the entire structure. Cableways carried cubic yards of concrete hundreds of feet above the canyon floor, lowering each portion into wooden forms precisely built to specifications. Steel reinforcement bars were positioned with painstaking accuracy, bent and anchored to counteract the river's pressure, thermal expansion, and even the occasional tremor from distant seismic activity. Each day, as the dam rose higher, every measurement, every bolt, and every cubic yard of concrete mattered. Observers from across the United States, and even Europe, flocked to the site. Skeptical engineers and journalists watched the project with disbelief, convinced that a river as untamable as the Colorado could never be held by human hands. Some predicted collapse within weeks of completion, pointing to the unknowns of concrete curing, the risk of uneven loads, and the potential for structural flaws. Yet the engineers pressed on, guided by calculation, experience, and unwavering confidence in their methodology. Beyond the technical challenges, the construction site was a theater of tension and ingenuity. Crews worked in unison, moving with the rhythm of a complex machine. Every day presented new obstacles, shifts in temperature, unexpected rock formations, sudden changes in river flow. Engineers recalculated angles and loads, sometimes altering the course of the project mid-pour to accommodate unforeseen conditions. Yet every adjustment, every innovation became a part of the growing monument, a testament not only to human knowledge but to resilience, foresight, and discipline. As the dam began to rise, layer by layer, it became a symbol. A symbol that human ingenuity, careful planning, and absolute precision could confront nature at its most formidable. Concrete was no longer just a building material. It was a canvas for engineering ambition, shaped by the hands of men who understood that in this canyon, nothing less than perfection would suffice. And as the Colorado River continued its relentless course below, churning and roaring, the world began to witness a transformation. The wildness of nature bending, ever so slightly, to the precise calculations and tireless labor of those daring enough to dream big. Doubt was never far away. European engineers, familiar with early concrete dams in Switzerland, Italy, and France, openly criticized the project. They cited every failed dam as proof that Black Canyon would succumb to the river's force. Newspapers called the dam a death trap and described it as a gamble with the lives of thousands who might someday depend on it. Letters from legal advisors warned of liability in case of structural failure. Insurance companies were hesitant to provide coverage, and some engineers on site privately questioned whether the dam would ever survive beyond the first winter. Even with the pressure mounting, the chief engineers pressed forward. They had spent months analyzing rock samples, calculating hydraulic loads, and running stress tests on small-scale models. They believed the arch design, paired with precisely mixed concrete and reinforced foundations, would succeed where others had failed. Their calculations considered every variable: the canyon's curvature, the strength of the rock walls, the thermal expansion of concrete, the river's peak flow, and even long-term erosion. Critics dismissed these analyses as theoretical, but the engineers knew that careful observation, meticulous measurement, and systematic planning could turn theory into reality. Where skeptics saw risk, they saw opportunity, the chance to create infrastructure that could last for centuries rather than decades. Their confidence was not arrogance. It was grounded in exhaustive study, repeated testing, and the careful control. Construction of the dam demanded a level of precision that stretched both human skill and material science to their absolute limits. Every cubic yard of concrete was scrutinized before it was poured, mixed to exact ratios of cement, sand, gravel, and water. Engineers monitored every batch, aware that even the slightest deviation could compromise the integrity of the structure. As the concrete was poured, it was not left to its own devices. Temperature gauges tracked heat generated by the curing process. Cooling pipes ran through the mass of the dam, and workers sprayed water strategically to prevent cracking. Every phase of curing was a controlled experiment in progress, a delicate balance between chemical reaction and mechanical stability. Steel reinforcement bars were bent and positioned with painstaking accuracy, each one designed to carry specific loads, distribute stresses evenly, and work in harmony with the massive concrete forms surrounding them. Foundations were drilled deep into the canyon's bedrock, sometimes hundreds of feet below the riverbed, but the engineers quickly realized that nature had its own plans. Hidden fissures and fault lines in the canyon walls threatened stability, forcing teams to reinforce sections on the fly. Designs were adjusted mid-construction, calculations recalculated, and material redistributed, all without halting the momentum of the project. The work itself was exhausting. Crews operated around the clock, often in extreme heat and biting winter cold, constantly checking measurements, adjusting cooling systems, and monitoring the alignment of each section. Cableways carried tons of concrete and steel high above the canyon floor, lowering massive sections with millimeter-level precision. Even the smallest error, a misaligned steel rod, a slightly tilted form, could have had catastrophic consequences, rippling through the structure and jeopardizing the entire dam. Every movement, every placement demanded complete focus. Precision extended beyond materials and measurements. Labor management was just as critical. Workers were trained to follow exact procedures, leaving no room for improvisation. Any mistake, however minor, was corrected immediately. Supervisors moved among crews like conductors in a symphony, ensuring that every action contributed to the harmony of the project. This culture of meticulous control transformed the workforce itself into an instrument of precision, where human discipline reinforced the engineering philosophy embedded in the concrete and steel. As the arch began to rise, layer by layer, it became clear that the dam was more than just a construction project. It was a living demonstration of what could be achieved when human skill, careful observation, and material mastery converged. The rising structure reflected not only the engineers' technical expertise, but also the relentless dedication of the workers who executed every task with unwavering discipline. In the black canyon, what had once seemed impossible, a river too wild, a gorge too narrow, a construction task too complex, was being transformed into a monument of order, precision, and human ingenuity. By the time the arch took full shape, it was evident that the dam was not simply concrete and steel. It was a testament to systematic planning, rigorous oversight, and the remarkable ability of human beings to impose order on forces far greater than themselves. Every joint, every bar, every cubic yard of poured concrete told a story of patience, courage, and relentless pursuit of perfection. In Black Canyon, the impossible was becoming reality, one precise measurement at a time. 1936 brought the moment of truth. The dam, a colossal structure of concrete and steel, stood completed, rising from the narrow Black Canyon like a monument to human ambition. But all the calculations, all the engineering feats, all the years of labor would be meaningless if it failed to hold the one thing it had been built to control: water. For engineers, workers, and observers alike, the first filling of the reservoir was a tense, almost sacred event, a test that would prove whether decades of innovation and daring had been worth the risk. As the Colorado River flowed into the newly constructed reservoir, the water rose slowly at first, lapping against the base of the dam. Engineers monitored every sensor, every gauge, every joint. Strain indicators measured minute deflections in the concrete, and expansion joints, designed to accommodate natural movement, responded exactly as predicted. Every reading, every observation was meticulously recorded, compared against years of calculations and theoretical models. In that moment, the abstract numbers and diagrams of engineers' desks became living reality, as the dam met pressure, unlike anything it had ever experienced. By midweek, the water had risen to levels never before contained by a man-made structure. The river's force pressed against the dam with an intensity that, decades earlier, would have seemed unimaginable. It was not just a test of engineering, it was a battle between nature's raw power and human precision. Spectators watched from the canyon rim, holding their breath as the water pushed against the towering arch. Yet the dam remained unwavering. There were no cracks, no groans of stressed concrete, no hint that the structure might fail. The arch design, so radical and untested at this height and thickness, performed perfectly, transferring the immense hydraulic pressure laterally into the canyon walls. Engineers moved like priests performing sacred rites, checking readings, recalibrating instruments, and documenting every millimeter of deflection. It was both exhilarating and nerve-wracking. For years, their plans had relied on theoretical models and laboratory tests. Now, the Colorado River itself provided the ultimate validation, or the ultimate condemnation. Yet, as the reservoir continued to fill, a pattern emerged. The concrete responded as designed. The expansion joints accommodated movement exactly as intended, and the stress readings fell precisely within projected ranges. Every hypothesis, every calculation, every painstaking decision made during construction had been justified. As the reservoir neared capacity, the crowd watching from the cliffs erupted. Engineers allowed themselves rare smiles, some even shaking hands and patting shoulders, a release of tension built over years of relentless work. The river, once considered untamable, had been harnessed. What had once seemed impossible had been achieved. Skeptics were silenced. Newspapers that had once gleefully predicted imminent disaster now reported cautiously on the triumph, describing the dam as a testament to human ingenuity and a new benchmark in engineering excellence. For the engineers, however, the victory was deeper than public approval. It was proof of a philosophy, one that placed preparation, precision, and total control over every element of construction above shortcuts, cost-cutting, and guesswork. Every cubic yard of concrete, every embedded steel rod, every carefully calculated joint had mattered. The dam was no longer a gamble. It had become living evidence that meticulous planning, innovation, and human determination could bend even the wildest forces of nature to human will. As the last feet of water settled into the reservoir, the Colorado River lay calm behind the towering concrete wall. It was not merely a body of water restrained, it was a symbol that engineering, when paired with foresight, discipline, and courage, could achieve permanence. And in that moment, everyone present understood that this was not just a victory for a single project, but a milestone in the history of human innovation, a triumph that would inspire generations to come. In the decades that followed, the dam faced tests no engineer could have fully predicted. Massive floods in the 1940s pushed it to its limits. Earthquakes shook the canyon walls, sediment built up behind the reservoir, and water levels fluctuated beyond historical averages. Yet the structure endured. Minor repairs were needed over time, but the arch continued to perform with virtually no degradation. Engineers and scientists studied the dam as it aged. They measured deflection, stress, and wear patterns, confirming that the original calculations and construction methods had succeeded. Modern dams, often built for speed and cost efficiency, rarely lasted this long without major intervention. Black Canyon's dam became a case study in durability, showing the world that quality and precision could outperform expediency and cost-cutting. The dam's endurance was a lesson. Infrastructure built with foresight and care could serve generations, defying the predictions of even the most skeptical experts. Today, nearly a century after its completion, the 1930s dam continues to stand as a monument to human ingenuity. It provides electricity, water storage, and flood control for millions of people. Modern dams built with a focus on cost and speed often fail within decades. Yet this dam, built when the world doubted concrete and arch design at this scale, remains structurally sound, requiring minimal maintenance. Its survival is a testament to meticulous engineering, careful material selection, and unwavering attention to detail. The Colorado River, once wild and untamable, now flows under a structure designed not just for today, but for the next 100 years. Engineers, students, and historians study it as a model of permanence, demonstrating that vision, skill, and science can defy skepticism and transform the impossible into reality. This dam is more than concrete and steel. It is a lesson in the enduring power of human ingenuity, a silent testament to what happens when precision meets ambition, and a reminder that sometimes building to last is the greatest achievement of all.